So today we'll study 2-bit up-down counter. Okay. Two-bit up-down counter. So yesterday we studied 2-bit up counter and 2-bit down counter. Okay. So and 3 and 4-bit we have already done, right? So today we'll study 2-bit up-down counter. Now for 2-bit up-down counter, what you need is you need to flip-flop. Zeta flip-flop signs are there. In a similar manner. Zeta flip-flop signs up. And this is QA complement, this is QB complement. And there's a negative edge trigger, lock. And it works, the key should be equals to 1. And with the output QA and QB. Right. So this is FA, this is FFB. Okay. So what we are going to do is we are going to see, we want to design both up and down, and we know that we will ignore I, we know that if the realize if we connect QA complement to the block of next stage, block then become down. You got this, sir? Means I'm going to this QA line is my feed variable. It will become up counter and QA complement feed variable. You will not count, right? Therefore, we need one select line, say N, to realize means we need one selection line. We need one select line, say M, that can select between QA and QA complement. From that selection, ready selection line, what you can do is you can choose between the QA and QA complement. So that now using single selection line you can convert this counter into up counter or you can convert this counter into down counter. So basically you need one conversion circuit. So therefore we need to design a combinational circuit which looks like zero diagram. So what basically it is when you run combinational circuit. Circuit where we have two inputs, this QA and QA complement, and one selection line that is M and zero output. Okay, this M is nothing but and what about Y? Y, what we write is connects flow of next stage to clock. Okay, connects clock of next stage to clock. So what we want when M is 0, when M is 0, QA should be selected. QA should be connected to Y or selected, right? And when M is 1, QA complement should be connected to Y. So we will make a table like this: M, QA, and QA complement, and there is Y. And write all the possibilities 0, 0, 0, 0, 0, 1. All the possibilities of this combination, because there are three inputs. There are three inputs, right? So since there are three inputs, so these are the possible combinations of the inputs. And what is the and as I said, let's assume when M is equal to 0, Y is equal to QA, and when M is equal to 1, Y is equal to QA complement. Let's assume somewhere. If M value is 0, then yes, Y is equal to QA. That is for upcounting. And when M is equal to 1, Y is equal to QA complement. So knowing that, अब यहाँ ध्यान देना so जब M value 0 रहेगा, जब M value 0 right? किस साइन से when M is equal to 0, what should be Y? Y is equal to QA. So Y will be equal to nothing but QA. So QA value किस है? 0, 0, 1, 1. And when the value of M is 1, then what is the value of Y? QA complement. And what is QA complement? 0, 1, 0, 1, 0. So this is the output that I need. And now let's solve this by using K map. Using K map. This M, this QA, QA complement, 0, 0, 0, 1, 1, 1, 0, 1. And let's put the values 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. So let's make a group. This is G1 and this is G2. So our vector y will be equals to G1 plus G2. And what is G1? M complement QA, M complement UA plus what about G2? M QA complement. Yes, M QA complement. Clear? So this is what we got. Right. This is what we got as well. Okay. And this is what we require. This is done. Now see, it's not yet completed. We got the value of phi, na? We got the value of phi. Now, this we have to realize now using logic diagram. Okay. That means what we have to do is see you know that this phi, what is this phi? Phi is going to connect its clock of next clock means certain circuit we need over here. जहाँ हाम्रो QA complement र M इनपुट छ के यहाँ सर्टेन सर्किट चाहियो हामीलाई जसको आउटपुट हुन्छ त्यो हामी यहाँ कनेक्ट गर्छौं हैन अनि इनपुट चाहिँ QA कम्प्लिमेन्ट र M अब यहाँ छैन हो के हैन सो हामीलाई M चाहिएको छ यस सो दैट्स राइट सो पहिलो कुरा M let's take M somewhere here M को लागि एउटा लाइन लिम्पै एउटा नट गेट लगाएर and एउटा normal. You can take like this two inputs. For this is your M complement, and this is your M. And so, कुन गेट चाहिए इसको लागि? M complement QA को लागि AND gate. So QA यहाँ छ कि छ? एउटा AND gate चाहियो. Starting for AND gate. QA यहाँ छ कि छैन? I will get it here. And I need M complement. M complement का छ यहाँ छ माथि यहाँ एउटा M complement दिएर आउने. Clear? M complement QA. So this what you get is M complement QA. Similarly, you need M QA complement. QA complement यहाँ छ नि छ? Yes. M मात्र लिएर आउने. M यहाँ छ. And then you get M QA. Now you say you might ask, sir, your expression exclusive OR gate को. खास करके exclusive OR gate हो. तपाईले exclusive OR gate पनि ल्याउन सक्नुहुन्छ. But मैले किन ल्याएको? Basic gates बाट गर्नको लागि. Basic gates बाट डिपेन्ड गर्नको लागि मैले नगरेको. Okay, दुईटा आइसी र दुईटा के गर्ने अब दुईटा ल्याउने. All गर्ने okay. So that's all. And let's feed this into the clock of the next page. Yes. So now we're choosing M. Now this is your MSB. This is your MSB. Choosing this M, you can if M is 0, this will act like a up counter. If M is 1, it will act like a down counter. Okay, and if you don't believe me, you can check it out. Let's say M is 0 initially. Let's say M value is random 0 are. So if the M value is 0 are again, यहाँ के आंसर है 1, यहाँ 0, यहाँ 1 आंसर, यहाँ 1 आंसर. Right? And yeah, yeah, 0. So here what you get is 1 and this is QA. So 1 QA is QA. Right? And what do you get here? You get here 0. What do you get? 0. Now 0 plus QA is QA. So what you see, what is getting inside? QA. Means it is acting as a up counter. When M is 0, it is going to act as a up counter. Okay. And when Q is 0, right? And let's say if M is 1, if M is, so this will be 0 and this will be 1. Okay. So 1 means here 0 answer, here 0 answer. So here you get 0. Yes, and here you have 1 answer, so you get 1 here. This is QA complement. So 0 plus QA complement is QA complement. So you get, means it acts as a down complement. Your 2 bit को 3 bit में क्या होता? 3 bit में same theory, there is no difference. यही चीज आई है repeat loss, okay? Same diagram है. यही combination सर्किट हमें यहाँ repeat loss, okay? इंटर फ्लॉप आएगा नहीं? दो फॉर्म repeat होगा यार repeat होगा ना? यहाँ repeat होगा. And 4 bit को 4 चार फ्लॉप आएगा नहीं? तीनों डाउन होंगे. तीन repeat होगा. Same diagram. Okay, now then we homework. 3 bit or 4 bit को up down counter. 4 bit को exam में chances करना था. But अगर जाए 3 or 4 bit को practice करना होगा. Okay, now timing diagram. This is timing diagram. Timing diagram. Timing diagram में क्या बने? You have clock. 1. Trigger. So this block, this is first, second, third, fourth. And so when let's say m is equal to 0, so when m is equal to 0 means that this is completely 0, right? So when m is 0, now you need to plot QA and QB. So what will be QA? Let QA is equal to 0. So then toggles also, right? Then QA is, since m is 0, so what will be fed? QA will be fed, huh? M is 0, so QA will be fed actually, huh? To the clock of the next clock. So now Q is acting as a clock, negative edge clock. So let QB is equals to 0. QA is the clock. So let's do. So this is the clock now. So initially 0 sir, so answer was 0 answer. Which way 1 answer and then 0. With your let's write the values. So this is 0 0 0 1 1 0 1 1 0 0 again. So it is acting as a count image. So can you write the truth table for this? Okay. Now I want to write the truth table. You can write truth table by yourself also. I think. दूसरे भी डाल सकते हैं. M को value QB is the MSB, QA is the LSB. So clock is 0 clock, time is 0, 0 clock is 0 clock, and n is 0, 0 0. First clock, m is 0. What do you get? 0 1, and is decimal equivalent, na? Decimal 0 1. Then second clock, m is 0 1 0, and is 2. Third clock, n is 0, 1, 1, 3, and fourth of 0, 0 again, and that becomes 0 again. So this is similarly, you can write for down counting. In down counting, what will be there? N value 1 also, and here reverse sound, right? 0 0 1 1 also, 1 1 1 0. This is 0 1. This is 0 0.